Thank you, Mr. Chairman. A very good evening, everyone. Good evening. Great. Because since morning you're sitting, not speaking, people are coming here, speaking, giving lectures, so you should also get a chance to speak. All right, it's absolutely a pleasure to be here. Thank you very much, organizers, for giving the opportunity to make this presentation. Dr. Manish has made my life much easier by starting, but I would like to reinforce the message here because dams rarely fail suddenly. They fail silently from within. Most structural distress begins internally, long before cracks appear, long before visible warning signs. So in this presentation, I would like to show how integrated non-destructive geophysical techniques help us see those internal processes early and convert subsurface signals into confident engineering decisions. I am working in the field of dam geophysics since 1998. That's the first dam which I investigated. And so that has been a long time actually, almost 28 years now. One thing is that still there is a gap between geophysicists or people who are doing geophysical investigation and dam engineers. And that is something which through this presentation I would like to actually convey the message that there has to be a filling of this gap, and whatever subsurface signals we are having must be converted to confident engineering decisions. And we inspect what we can see, but structural safety depends on what we cannot. So we need to focus on areas which we are not able to see. Today we are focusing only on areas which we are able to see. That is mostly visual inspections, etc. Now, thank you. So now we are talking about why dam condition assessment needs a new approach. See, many of the dams, as the statistics was shown, are aging. I just walked from that place to this place, not for the effect, but here I can see the slides. There I cannot see the slides for some reason. All right. So many dams are aging under changed loading and hydrological conditions. Critical distress mechanism develop internally and progressively, as I said. Surface inspection, which we are talking about, I always like to compare it to medical science. I love to do that. So in medical science, what was the typical way of looking at the health? That is, we were seeing the pulse, we were touching the body, seeing the temperature, trying to understand what's happening inside the body, trying to understand what's happening inside the body. And then came medical imaging. When we were able to conduct X-rays, we were able to conduct ultrasound, we were able to conduct MRI. And today we no more just depend on temperature. We do not depend on the pulse rate. We rather do investigation. In case of dams, we are still doing more of pulse rate and temperature monitoring, temperature in the sense of just looking at the body of the dam, seeing what's happening, rather than measuring it inside. So all these surface inspections and even instrumentation provide limited visibility. They are not giving the continuous data within the dam body. Of course, the intrusive investigation, when we talk about like drilling and all that, in dams at least the structures as such is best avoided. And they are of course intrusive, costly, and again they give you point information. They do not give you continuous information. Now, from geophysics lens, if we look at, I'm a geophysicist, by the way, right? So I'm a qualified geophysicist from IIT Roorkee. 1990 is the year when I did my MTech in geophysics from there. And generally in the room like this, I'm the only geophysicist. This time there might be someone else, but generally that's the case. So when we talk from geophysics perspective, any change in the dam, for example, there is a seepage or leakage. What it is changing, the water content is going to change the resistivity or the conductivity of the dam material. Flow of the water through the dam body is going to develop a natural potential, what we call the self potential or streaming potential. If there is deterioration in the dam body because of leaching over a period of time, it is going to change the density inside the dam body, which in effect will change the P wave velocity, the compressional wave velocity. If there is an earthen dam and you see a subsidence there, it means there is a weakness developing which is going to change the stiffness in the dam body, which will be picked up by anything which is measuring the shear wave velocity. So the point is that whatever is the distress inside the dam body is going to change one particular physical property. And that physical property is being measured by geophysics. And that is why there are so many different methods. As Dr. Gupta said, you cannot depend on just one method. A single geophysical method is not enough because each geophysical method responds to a specific physical property. I'll just give you one example. Let's say we are measuring P-wave velocity, just P-wave velocity, compressional wave velocity. P-wave velocity of saturated sand is 1500 meter per second, of water is 1500 meter per second, of quicksand is 1500 meter per second, of clay is 1500 meter per second, and weathered rock is 1500 meter per second. So if you're just measuring one physical property, that is P-wave velocity, you will not be able to even differentiate between saturated sand and quicksand. Quicksand where you cannot put your foot there. So you have to measure different parameters, and then only you are able to characterize the material in a unique way. And which method you are choosing will have to be chosen based on what are you measuring. Now this is a big problem which is happening today in the country. Fortunately or unfortunately, over the years, many players come in the market and they start providing geophysical services. It's great. More people providing services means market will expand. Problem is, it becomes the case like a village when a person bought an X-ray machine. So if the bone is broken, I'll do X-ray. If you have some problem with your tissues, I'll do X-ray. If you have some problem here, I'll do X-ray, because the only machine he has is the X-ray machine. This cannot be done in the field of geophysics. For example, if you're looking at strength parameters, you have to go for seismic methods. If you're looking for water-based parameters, you have to go for electrical methods. So methods have to be chosen very, very carefully. If we don't do that, then it's best not to run a geophysical program. So integrated geophysical framework for dam assessment, it observes with what distress we are looking at, what problem we want to solve, and then decide on which method we are going to choose. It also will depend on geometry of the dam. What is the height to length ratio, etc., etc. So like electrical methods will identify moisture variation and seepage behavior. Seismic methods will give you strength, stiffness, foundation defects, etc. Cross-phase tomography will give you internal integrity. GPR will resolve shallow defects and discontinuities. So each method will answer a different question. The biggest point is the power lies in knowing which question to ask. What exactly we are trying to solve. Don't be method specific. Always be solution specific. As a dam owner, never take out a tender saying we want to do electrical resistivity imaging of this dam because it worked in some other dam. Don't do that. Talk to someone. There are a lot of people today. Dr. Manish Gupta has done a lot of work. We have Senthil sitting here in CSMRS. He has done a lot of work. I'm working since 1998 in this field. Talk to someone and understand which method will work in your dam. It's not a copy paste we can do from one dam to the other. Now for different problems, like for example, these are concrete dams, different issues, masonry dam, different issues, earthen dam, different issues. And there are methods here which we have characterized as most suitable, moderately suitable, and not suitable. I'm not going to read through the table. Idea of showing the table is that whatever is the issue or concern, or be it stilling, wasting, or canal leakage or foundation defect, there is one method or the other which is useful for that. Now coming to few case studies, because our time is very, very short. And when we come here and start speaking, time really flies very fast. It's always a problem. So this case study is of case identification of active seepage path. So it's an earthen dam. There is 3 zones which have been detected here, showing low resistivity 1, 2, 3. This is of course the rock level. This is all dam body. And these 3 zones having more water accumulation, but across this zone there is a prominent SP development. So resistivity shows where water is present and streaming potential reveals where it is moving. Simple. All right, so you know where the more water is present, you also know where the water flow is taking place. And once you do number of lines, so this line was done in the upstream of a dam, this was on dam top, and then these lines on downstream. And once you do these lines and put the resistivity and SP results together, you get what we call seepage path. These are the paths which you require to actually plan the entire rehabilitation plan of any dam. If you do it without this, it will be like trying to do a surgery without having results of your ultrasound and X-ray. So you'll keep cutting the body at every place. This is the next study of mapping weak zones linked to subsidence. So this was subsidence was observed at the dam, MASW was done, and the weak zones were determined where the velocity is low. So surface deformation is a symptom, shear wave velocity reveals the cause. This is seismic tomography. It is done between dam top and dam gallery. So here is a dam top. This is a dam gallery. Receivers are put there with no theory, but this is a 470 meter length. One day it took to do this entire investigation, and immediately you know the bad zones in the entire dam. If you don't have this information, you will start grouting from one end to the other, 3 meter by 3 meter, and end up wasting a lot of resources in doing that. Once you have done this and you know this is a problem in the L section, then across, and similarly you can multiple galleries. This is a 130 meter high dam, gallery 1, 2, 3, 4, and again weak zones in the entire dam. Once you know where the problem is, there you do the cross section between upstream and downstream, and now you know extent of this zone from upstream to downstream. No emptying of reservoir is required. It can be done when the reservoir is full. Then this velocity can be converted to density. So you know in the good dam, the density was, let's say, 2.5. Because of leaching, it has now come to 2.2 or 2.3. So 0.2 to 0.3 gram per cc has been a loss of density over a period of time. Based on this, you can actually plan, you can actually calculate how much grouting you will be required to do in the dam. Stirring basin, we have a practice of emptying the stirring basin for inspection. This is actually not required. Without emptying, using GPR and EcoSounder, this is a case study from Bhutan. We said that this is the area which is affected very badly. After 2 years, it was opened up and same area was found to be affected very badly, but it was not emptied just for inspection. So my time is up, so I'll just quickly go through my last couple of slides. Seismic refraction for foundation defects. You can know even the foundation defects in the dam. And canal seepage also we can find using ERI and SP. And ultimately, once you combine different methods, you are able to have more confident results. So geophysics adds value only when anomalies are translated into engineering decisions. Practical limitations are there, of course, because all these methods are inherently non-unique. Resolution depends on site condition, but it's a very powerful tool, but only in informed and experienced hands. We should choose our methods correctly and apply it correctly. Key takeaways are, of course, internal dam distress can be effectively assessed non-intrusively. Integrated geophysics reduces uncertainty in dam safety evaluation. Seeing inside the dam before distress becomes failure is the true strength of integrated geophysics. This is something we must take as a takeaway, that rather than doing any intervention in the dam, we should first look at it. When you should investigate it, ideally when the dam is built, to have the baseline data. Otherwise, before rehabilitation and after rehabilitation for sure. Before rehabilitation to know how to do rehabilitation, and after rehabilitation to know whether it has been effective. And these are my conclusions, that these investigations must be made an integral component of dam safety inspection programs and procedures, must be carried out before designing rehabilitation program and after. It's the concluding slide. And we have in a Dam Safety Act that we have to do all the 6,000 specified dams within the next 5 years. I think geophysics presents the only viable option for doing that. Thank you very much for your attention. Thank you, Chair, for giving me extra 1 minute for this.